Hello, dear students. Greetings of the day. I, Muhammad Zishan, welcome you to the online classes of geography. As you can see here, that it is written chapter number 7, Volcanoes. So, we are going to study today the chapter number 7 of geography, which is Volcano. This is the first lecture of that chapter. So, in this chapter, dear students, we will understand what is the meaning of volcano and from where this word volcano has been coined. Then we will understand the causes of eruption of volcanoes. Then after that, we will study about the types of volcanoes, right? And then we will be studying about the effects of volcanoes, destructive effects also and constructive effects also. So all these things we will be studying about. But in this lecture, we will understand what is the meaning of volcano and what are the causes of the eruption of volcanoes. So you must have seen a volcano erupting in movies or in some pictures. You must have seen that from an opening in the earth's crust or from the surface of the earth, hot material of red color, very hot, and it looks like some sticky material is there. That type of material is emerging out from the surface of the earth. You must have seen, like suppose if this is surface of the earth, then from here this type of hot material is emerging out, right? Not in reality but in movies. So that is actually volcano, right? And we are going to study about that thing. So first we will understand the etymology. Etymology means ke how the word, a particular word has been coined, right? And how a word got its meaning, right? The history of that, or you can say the history and development of the meaning of a word, that is called etymology. So here the word is volcano. So from where this word has been coined, have you ever ponder about that? So let me tell you that this volcano word has been evolved from an island and its name is volcano. Volcano is an island in Italy, okay? And there on that island, this particular phenomena of eruptions of lava takes place, right? And uh, because of that only it has been named as Vulcan or Volcano Island. Now that from that island only we have coined this particular geographical phenomena as a volcano. We have given a term volcano to this phenomena. Now that island also got its name from the name of Vulcan, the Roman god of fire or underworld, right? So in Roman mythology, there are various gods. Okay, uh, like Sol is there, right? Likewise, the god of fire, Vulcan is there, right? So according to that mythology, it is said that whenever the Roman god of fire or underworld means suppose this is world, okay, this is surface of the earth, right? Getting or not? So above the surface we are having our world, and below the surface, okay, which lies inside the earth, right? That is called underworld, right? Underworld, or in Hindi it is called patal, right? Patal lok or patal, right? So there is a god for underworld in Roman mythology, and its name is Vulcan. So it is said that when Vulcan stalk his hearth, right? Stalk means to blow air heavily or to increase the intensity of something, like you increase the flame of your burner while cooking food. Okay, you increase that, like that. Okay, likewise earlier there were stoves, and in stoves we used to increase the flame by doing like this again and again. Okay, so likewise in the hearth means chulha, right, or bhatti, you can say. Clear? We increase the flame by blowing air to that, right? So it is said that whenever Vulcan used to stoke his hearth, right, this hot material from the earth emerges out, right? This hot material from the earth emerges out, and that is called volcano, right? So according to the mythology, right, this word has been coined, but actually the reason of this phenomena is not whatever the Romans have told according to their mythology, but we will study about the scientific causes of eruption of volcano, and we will study all this in a scientific manner. We were just discussing that thing in order to understand from where the word has been evolved. Okay, where are the roots of this word, that we were trying to understand. Okay, after understanding the etymology, we will understand the definition of volcano. What is the meaning of volcano? So what is the meaning of volcano? A volcano is a vent. The definition for it: the volcano is a vent or opening in the earth's crust from which magma erupts from asthenosphere. So basically, volcano is nothing. It is just an opening or a vent in the crust of the earth from where the hot material, which is lava or which is called magma inside the earth, and lava on the surface of the earth. Okay, that magma erupts out because of the some endogenic processes, right, or endogenic reasons, right? Maybe pressure, heat, or several other reasons, right? It comes out on the surface of the earth. So that process or that thing is called volcano. So a volcano is a vent opening in the earth's crust from which magma erupts from asthenosphere. Now here, in this definition uh, we are just limiting the definition of volcano to earth only. What about the volcanoes on various other planets? There are so many planets in the universe. So have you ever thought that on that planets also volcano can take place? So in that case, what would be the definition of volcano? In that case, the definition will be that a volcano is a rupture in the crust of planetary mass object, right? uh, through which the lava flows out from its interior. Okay, that may be the definition. What we will do, we will just remove the earth and we will replace it by planetary mass, okay, or something like that. Okay, some other words. Now this will be the definition. Now we will study about the meaning, not meaning, about the causes of the volcanic eruptions, right? So what are the causes of volcanic eruptions? For volcanic eruptions, we need to have three things. First of all, we need to have a material which is supposed to be taken out or thrown out from the interior of the earth. Okay, that material is magma, right? Second thing, we should have a force or pressure to throw that out. Okay, and third thing is that we should have the cracks, okay, in the earth's surface, because earth's surface is very thick. Okay, the earth crust, we talk about the average thickness of the crust is around 80 to 70 to 80 kilometers. Okay, so that in order to break, it is not a very easy task to break a sheet of 70 to 80 kilometer thick, right? So there should be fault, right, or there should be fault in the earth crust, or there should be some weaker rocks, okay, which may generate the faults in the earth crust. So three things are required. First thing is the material which is supposed to be taken out. Second thing, the pressure by which the material will be taken out. And the third thing, the way, okay, from where the material will come out. Okay, if we are having these three things, then volcanoes will take place. So right, we are having the three causes of volcanic eruptions. First is heat and pressure inside the earth. Now, dear students, I have taught you in last chapter, in the landforms chapter, I have taught you in, about the tectonic plates, and in the chapter number, let me check this, in the interior of the earth structure, chapter number 4, I have told you about the interior of the earth, about the core, about the mantle, about the crust. Okay, everything is there. So if you don't know the details about the interior of the earth, then you can do one thing, you can go and check my last videos, and then you will come to know a lot about the interior of the earth, what type of interior our earth is having. Okay, so, for now, let me tell you that the interior of the earth can be divided into three parts. The upper one surface is called the crust, and then in the middle one we are having mantle, and the central one is core. Okay, so it is said that whenever we go 65 degree below, right? Whenever we go 60, not degree, 65 feet downside, okay, then the temperature rises by 1 degree Fahrenheit. Okay, 1 degree Fahrenheit. So when we will keep going downside in kilometers, then what will happen? The temperature will become tremendous, right? So we have studied in last lectures that inside the earth the temperature is very high. Okay, and in the core of the earth the temperature is around 6000 degrees Celsius to 9000 degrees Celsius. That is huge. Okay, if you water get boils at 100 degrees Celsius, and if water falls on your skin, then what will happen? You will get burns. Okay, your entire skin will be burned. And so what about 1000 degrees Celsius, 2000 degrees Celsius temperature, 3000 degrees Celsius temperature, or 5000 degrees Celsius temperature? If something, if your body, if you touch, okay, something which is very hot, around 1000 degrees Celsius, then what will happen? You will dip your finger inside that, and when you will take out your finger, you will not find your finger. Okay, your finger will be melted completely. Getting or not? So that temperature is very high. Okay, so because of very high temperature, what is happening? Because of that, the pressure is also getting increased. So in the interior of the earth, we are having very high temperature as well as high pressure, right? And because of that high pressure only, right, the material which is inside the earth, which is in the asthenosphere, is tries its best to come out and to release the pressure, right? So this thing we will understand by the example of pressure cooker. I have drawn there pressure cooker. You must be wondering why sir has drawn this pressure cooker. Will sir make some food or what? Okay. Yes, we are having here pressure cooker, and by the example of pressure cooker, we will understand the eruptions of volcano, how volcano erupts. So, you all have seen pressure cooker. In pressure cooker, there is a whistle, right? And that whistle, uh, when you burn fire, and after that the food starts cooking, and inside it, because of water, the steam's generated, and steam put pressure on its wall upside. Okay, steam put pressures upside, and then what happens then? From here we are having a hole right below this vessel, and from this hole, right, this steam tries to come out. Okay, and it exerts pressure on the vessel, and vessel is uplifted this way, and then what happens? Then this steams come out. Okay, then the steam come out. So what is happening here? Here, when the temperature is very high downside, and because of that, the food is getting cooked, okay, and steam is getting generated. That steam is applying pressure. Pressure is becoming higher and higher here, okay. Pressure is increasing. Because of that high pressure, right, our food will be cooked. And if that pressure will keep on increasing and increasing and increasing, what will happen? It will apply force on the surfaces of the pressure cooker, right? So hence, from through this opening, okay, through this opening it will apply pressure on this vessel also, okay. And vessel is not fixed in the cooker, it is just, it can be uplifted very easily, okay, if the steam is applying force from inside, okay. So that way what happens, the steam comes out, right? So it is just like a volcano, you can say it is just like a volcano, means the material, the steam which was inside the cooker is coming out, okay. Now second thing is here, that case in some time, if the whistle is not working properly, right, the whistle is not working properly, let me check the duration of video. If the whistle is not working properly, then what will happen? In that case, we are having here, this one is safety valve, okay, this one, we are having this safety valve, safety valve, right? This one is safety valve, clear? So what will happen when this opening is blocked, okay, and the steam is not getting way to come out from here, then what happens? What is this safety valve? This safety valve is nothing, it is a valve of thin layer. The layer, these layer of pressure cooker is very thick, okay, the steam cannot break it. But here at this place on the cap of pressure cooker, right, at this place the layer is very thin, okay. So it is kept thin. Why? In case when this whistle do malfunctioning, then in that case, when the steam will keep generating and the pressure will become very high, then what will happen? Then this will be broken, okay, and the pressure will be released from here like this, okay. The steam will be released from here. Getting or not? That is why it is called safety valve. In case if this safety valve was not there, right, then what would have happened? This steam will be generated inside it, okay, and that pressure will become tremendously large, okay, very high pressure would be there. So here downside you are burning fire, right, and in this the steam is getting generated, pressure is becoming higher and higher and higher and higher, the pressure will become very high that this entire pressure cooker will be burst out, okay. So what will happen? Here the cooker will burst out, okay, burst out, right, like a bomb, doom, right, getting or not? Then the entire pulses or vegetables, right, will be eaten by our roof and walls, not by us. And if you are cooking food there, right, you are standing there, then anything mishappenings can also take place, okay. Some injuries, serious injuries may also takes place. So this valve is called safety valve because of this reason only, right? So likewise in our earth, this is the earth crust, suppose this is the earth crust, okay, and in earth crust we are having some weaker rocks, okay, some weaker layers of rocks, from where the pressure which is getting generated inside the earth is released, okay. So that is why the volcanoes are called the safety valve of earth. Volcanoes are called safety valve of earth. Volcanoes are called safety valve of earth. Now I have made so many concepts clear by the example of this pressure cooker. Now it will be easier for you to understand the phenomenon of volcano and the mechanism how it takes place. So the first thing is that okay, inside earth, right, this much is suppose crust, this is crust till here, okay, this is crust, hmm? This is crust, and here suppose this is mantle or asthenosphere, okay, just this is suppose asthenosphere or the upper portion of mantle, okay. So in mantle, the temperature, or in asthenosphere, temperature is very high. The temperature is around 2000 degrees Celsius to 4000 degrees Celsius, okay, and more than that, okay. The rock materials, the rocks can melt at 1400 degrees Celsius temperature. So it means that all rocks will be in molten form. Okay, the rocks here in the crust are in the solid form, and downside what will happen? The rocks will be in the molten form. Okay, so because of that large temperature, very high temperature, what happens? Inside it, rocks are there. Rocks are made up of silicates. Okay, so these rocks of silicates, they are very bad conductor of heat. They cannot, let the heat travel through themselves. But what happens? They get melted themselves. Okay, so and in that water may also be there, okay. So inside it we are having the molten rocks plus the water vapor, right, plus various volatile gases, and so many other things are there. So all these things exert pressure, right. Water vapor exert pressure upside, these all materials exert pressure upside. So we are saying that heat and pressure inside the earth, this heat and pressure, the pressure, uh, this pressure tries to get released, okay. Pressure, if pressure is not getting released, then what happens? Then troubles takes place, okay. Even the pressure of your stomach is not getting released, then there will be problem for you. And we people very frequently release the pressure, and the fart is the best example of the human volcanoes, okay. Now so what happens? This pressure, because of this pressure, the hot material, right, ascend upside. And where it will ascend? See here, the blockage is there. Okay. So if suppose there are cracks, if there are cracks inside it, okay. Second thing we are talking about tectonic plates. Achha, let me tell you about magma chamber first. So because of the high pressure, right, I have already told you the rocks are in molten form. Okay, magma is what? Magma is molten rocks, gases like CO2. Magma is molten rocks plus water vapor plus gases like sulfurated hydrogen, CO2, right, nitrogen, and etc. The material which is supposed to be taken out is there inside the asthenosphere. Means when, because of the high temperature, the rocks get melted, so one chamber of magma get ready, okay. So that chamber is called magma chamber. Means it is, you can say, okay, the place where the availability of magma is there inside the earth, that place is called magma chamber. So in that magma chamber because of the high pressure, right? And that high pressure may be generated by the by the presence of some highly radioactive materials in which some chemical reactions are taking place and heat is getting released, right? And because of that, pressure is getting increased. Okay, so that is there. So this magma chamber is there. Now pressure is there, heat and pressure is there, magma chamber is there. Now the role of tectonic plates comes. Okay, what is the role of tectonic plates? Tectonic plates generate faults in the earth's crust. Okay, we have studied in our last videos, I have told you about the 7 major tectonic plates. I have told you the names like the Pacific Ocean plate, North American plate, South American plate, and Eurasian plate, and African plate, and Arctic plate. Sorry, not Arctic, Antarctic plate, and the Indo-Australian plate. So these 7 plates are the major plates. Okay, and like Nazca's plate and Cocos plate, these are the minor plates. I have told you in the last video. Okay, you can check that. So suppose if here, suppose if here, this is the tectonic plate T1 and this is the tectonic plate T2, and they are moving away from each other in this manner, right? From here they are moving away from each other. So what will happen? Suppose this is T1, this is T2. So what will happen when they will move this way and they will move, it will move this way? Then what will happen? Inside here some cracks will be, faults will be generated. Okay, some faults may be generated like this. Getting or not? So when these faults will be generated, what will happen? This magma is ready. Okay, this magma was just looking for it only. Okay, the pressure was the tremendous pressure was just looking for a chance to be released. Okay, from there. Getting or not? Then what will happen? This magma which is putting pressure upside, okay, will crack this, okay, and will ascend like this. Okay, and what will happen? And then it will be evolved this way. Okay, this will happen, right? When blast will take place, and with that blast this magma will come out, okay, on the surface of the earth. Okay, and that will be called volcano. That will be called volcano. So this is how volcanoes are generated. Okay, so let me just read a few things from your chapter book. Heat and pressure inside the earth, temperature and pressure both increases from the surface towards the center of the earth. I have already told you 65 feet. When we go downside, then temperature is increased by 1 degree Fahrenheit. Rocks are bad conductors of heat, I have told you. So the earth's heat does not escape on its own. Instead, it melts the rocks and build up great pressure. The pressure forces the heat to find and escape. The pressure forces the heat to find and escape, right? Through a route, okay? It may be through a fissure, right? Or an opening vent. Now, what is here? This is a vent. Okay, this is just a opening. Okay, down here like this. Okay, this is the opening. Let me show it by blue color. Here, by this opening, this material is coming out. Okay, so it is a volcano. And if suppose the faults was there like this, this is the fault na here like this, right? If the volcano, if the material is coming out throughout this fault, okay, in a linear form, right? So that is called fissure. That is called fissure. This is the difference. Okay, fissure means eruption of lava from a crack in a linear form. That is called fissure, and eruption of lava through a circular opening is called what? Volcano. That is the difference, right? Then plate tectonics. Most volcanic eruptions takes place near plate margins. Okay, so plate margins are there. Plate margins means plate boundaries are there. Like suppose if most of the volcanoes takes place on the Pacific Ring of Fire. Okay, in the Pacific Ocean is there, right? Pacific Ocean, we are having Pacific tectonic plate is there, and the Pacific tectonic plates and the North American tectonic plates and the South American tectonic plates and the Pacific plate and the Indo-Australian plate, Pacific plate and the Eurasian plate. Okay, at the boundaries of these plates, the volcanic eruptions takes place. Why? Because at boundaries only cracks are generated. Okay, when the plates move away from each other, right, like this, cracks are generated, and at boundaries only subduction takes place. Okay, like suppose this plate is moving this way and this plate is moving this way, then what will happen? The crumbling of the ground will takes place and the oceanic plate will subduce downside. Okay, it will be subducted downside the continental plate. Okay, and that will generate some faults. Okay, or when it slide past, so whatever activity, the cracks will be generated near the tectonic plate margins only. Okay, so that is why the most of the volcanoes takes place near the tectonic plate margins only. And one thing is also there, it is said that most tectonic plates, sorry, most volcanoes takes place on the coastal regions. No, right, not on the coastal regions or every coastal regions, but on the coastal regions where two tectonic plates are either converging or diverging from each other. So what will happen if there is an oceanic plate, there is a continental plate? Okay, and there if faults are getting generated, then the water of the ocean will seep downside. Okay, will seep downside the earth. Okay, and that will be boiled by the tremendous heat inside that. Okay, and steam will be generated, and that steam will work upside. Okay, that will apply pressure, right, and the volcano may takes place. That is the reason. Okay, why the volcanoes takes place on the coastal areas of the converging or diverging tectonic plates. Okay, that is the reason. So this is how the volcano takes place. I have told you, right? I have told you about the magma chamber, about tectonic plate, about heat and pressure. In next video, we will talk about the products of volcano and the structure of volcano. Thank you so much.